All right, we're going to do some periodic trends here today. The first one on your notes talks about the nonmetals, where they're located at. They're to the right of the staircase. On the staircase is the metalloids, and to the left of the staircase are the metals. And you're going to see as we get going, there's more and more things that we develop. Like the metals become positive ions, okay? The nonmetals become negative ions, and the metalloids separate those two. They have properties of both. All right, so the three main periodic trends that we're going to talk about today. The first one is called the atomic size or the atomic radii. All right, so when you're talking about atoms, we talked about the energy levels, and as they go down, every period you increase in energy level, right? Well, the atoms are going to be bigger. The more energy levels you have, okay, the atom is going to be bigger. So the trend is it increases going down the group. All right, so going down the group, you have more energy levels, so they are going to be bigger. All right, and it's going to decrease going across the group. So it increases from right to left, but it decreases from left to right across the group. And this is why. It has more protons, because, right, the protons, the atomic numbers go up, right? So you're adding protons going from left to right. The more protons there are in the nucleus, the greater charge you're going to have, the greater positive charge, which is going to pull the electrons in just a little bit. So it's not that big of a difference, but as it goes across, it's going to get a little bit smaller, a little bit smaller, a little bit smaller, because the more protons, okay, are going to pull it in tighter, all right? The greater the charge in the nucleus, the more pull on the electrons to pull it in tighter, all right? So it's going to get smaller going from left to right. Now, electronegativity, right, is a trend. It's how likely you are to gain an electron. All right, so how likely are you to attract an electron? So it's basically a measure of your attractiveness. So how likely are you to gain an electron is what electronegativity means. All right, and it increases from left to right, and it increases from bottom to top. And fluorine is the most electronegative element on the periodic table. We don't use the noble gases because they don't attract electrons, right? And we talked about this earlier about how nonmetals are going to gain electrons to become negative ions. So if you're trying to gain electrons, are you likely to gain electrons? Yes, you are. Metals, on the other hand, are looking to give up electrons, not gain. So their electronegativity, the metals over here, are going to be very small because they don't want to gain electrons anyway. All right? So nonmetals will be higher because they want to gain electrons. All right? And it increases from bottom to top because the closer you are to the nucleus, the more likely you are to get attracted to that, to gain an electron. So the ones that have, there's a nucleus, and then we've got a ring here and a ring here. Okay, this electron, okay, the nucleus is closer, so it's more likely to pull in other electrons. When you've got an atom that has a ton of rings, and those electrons are really far away from the nucleus, then the likely to attract electron isn't as high. Okay, and then ionization energy, all right, is how much energy it takes to remove an electron. All right, so think about this. The metals want to give up electrons, right? So it's not going to take much energy at all for the metals to lose an electron. All right, so they're going to have low ionization energies over here. The nonmetals over here, they want to gain electrons, not lose electrons. So their ionization energies are going to be very high because they don't want to lose electrons. They want to gain them. So how much energy does it take to remove an electron? Well, for fluorine, it takes a lot of energy because fluorine's like, hey, I just want to gain one real quick and be done. It doesn't want to lose one. It's got 7. It's only 1 away from 8. So if it has 7, it's only 1 away from 8. The last thing it wants to do is go back down to 6 because then it has to gain 2. All right, so the ionization energy trend is going to increase from left to right and from bottom to top again because it's the same thing with the nucleus. The closer you are to the nucleus, it's going to affect that trend. So how do you remember that? Well, what you do is you take your hands, okay, and you make a box. So put your pointer fingers together and your thumbs like that, and you're making a square, all right? Now, atomic radii is going to be your left hand, like a loser sign, right? You're making an L, right? It increases from top to bottom, and it increases from right to left. So it increases into your palm. Increases from top to bottom, increases from right to left. That is atomic radii, okay, and atomic size. So if I'm asking you which one is bigger, lithium or potassium, which one's bigger? Potassium, because it's bigger going down, right? Which one's bigger, iron or potassium? Potassium, because it's bigger going that way. All right, going across from right to left. So you're looking at the trend. They're always going to give you, especially in high school, they're going to give you the same group that you're comparing, or they're going to give you the same period you're comparing. So if you know the trend, you got it. So my left hand is atomic radii and atomic size, right? You just got to make sure your palm's out like that. All right, now, I eat with my right hand. I eat with my right hand. All right, so on my right hand is my electronegativity and my ionization energy trend. It increases from left to right, and it increases from bottom to top. Remember, it increases into your palm. Okay, so when I look at that, if I say which one has a greater electronegativity, carbon or oxygen? Electronegativity increases from left to right, and it increases from bottom to top. So which one has a greater electronegativity?
Oxygen.
Oxygen. Which one has a greater electronegativity? Arsenic or phosphorus? Phosphorus, okay? So just remember, fluorine is the most electronegative, and fluorine is has the highest ionization energy. So, I eat food. Fluorine and food both begin with F. All right? So if you can't remember, just think fluorine. So fluorine's the highest, left to right, bottom to top. Fluorine's the highest, left to right, bottom to top. Atomic size, francium, is the biggest over here. Biggest element on the periodic table, Fr. All right? So those are your atomic trends or periodic trends and how to remember them.